How does electrostatic discharge, ESD, break electronics? Imagine holding a balloon after rubbing it on your hair and then accidentally touching a metal doorknob. That tiny spark you see is a tiny version of what happens inside electronic devices during electrostatic discharge. ESD is a sudden releases of static electricity that can happen anytime static builds up on your body or objects around you. When this static jumps to an electronic device, it can cause serious damage. Electrostatic discharge occurs when static electricity stored on an object suddenly finds a path to ground or another object with a different electrical potential. This transfer happens very quickly, often in less than 100 nanoseconds, and can generate voltages of thousands of volts. For comparison, a typical static shock from walking across a carpet can be a few thousand volts, but inside tiny electronic parts, even a fraction of that can be harmful. Inside electronic components, high voltages and currents from ESD can punch tiny holes in insulating layers within semiconductors. These layers act as barriers to control current flow, but when punctured, they allow uncontrolled current to pass through. This can permanently damage the delicate structures inside chips. The sudden surge of current also produces intense localized heat, which can melt tiny metal connections inside the device. Metal traces and contacts in circuits are very thin and fragile. When a high current flows through them unexpectedly, they can melt or break, creating open circuits or shorts. Over time, repeated ESD events can cause atoms in metal layers to migrate, weakening connections and leading to long-term failures. Modern electronics are especially vulnerable because they are built with very small features and thin insulating layers. Components like metal oxide semiconductor field effect transistors and bipolar junction transistors are sensitive to even small static shocks. Damage may not be immediately visible, but it can cause devices to malfunction or fail unexpectedly later on. Failures caused by ESD can be soft, meaning the device temporarily malfunctions or resets, or they can be permanent, destroying the component completely. Sometimes, damage is hidden inside, causing latent defects that weaken the device over time. These latent issues can lead to failures weeks or months later, making diagnosis tricky. In real-world troubleshooting, ESD is often overlooked because damage isn't always visible externally. Many failures happen suddenly without obvious signs, but understanding how static can cause internal damage helps technicians identify ESD as a cause. To prevent this, workers use grounding straps, anti-static mats, and handle devices carefully, especially during manufacturing or repair. Protecting electronics from ESD is about controlling static buildup and discharge. Keeping humidity levels high, using anti-static wrist straps, and designing circuits with built-in ESD protection help reduce risks. Recognizing how ESD silently degrades or destroys components helps explain many mysterious device failures and guides better protective measures.